Hello everyone, welcome back to my channel. Let's discuss today's problem. Problem is minimum remove to make valid parentheses. We'll be discussing two approaches for this problem. Let's get started. We are given a string. So see what we are given is we are given a string s of opening brackets, closing brackets, and lowercase English characters. Your task is to remove the minimum number of parentheses, that is this opening or closing brackets we have to remove from any position, fine, so that the resulting parenthesis string, the whatever, like after removing whatever resulting string is there, is valid, and return any valid string. That is, we have to create we have to remove the brackets in such a way that we get a valid string. So the question is now, what is valid string? A parenthesis string is valid if and only if it is empty string, contains only lowercase characters. That means like only if there are letters. Let's say Leetcode. Like simply here in this string there are only letters. So this is a valid string. This is a valid string. Other could be that it can be written as AB, A concatenated with B, where A and B are valid strings. So what could be like, there could be A and B strings which are themselves valid. Fine, this is also valid and this is also valid. Or it can be written as this, where A is a valid string. So brackets, we should like have one opening and one closing. So this is valid. One opening, one closing, and whatever the string is. Fine. So this we have to make. That is, we have to like simply basically what we have to do is we have to remove which all the unnecessary brackets which are there, extra brackets which are not balanced. Let's see this example. So see this input. I have written it over here. So let's see this. Over here, just try to figure out what will be the unnecessary bracket. What is unnecessary bracket here, which we should remove. So from this only, from the inputs only, like we will go through each test case, and from that only you will be able to get the approach. So see here. Here what is there? This is one opening. Then we have another opening. Then we have closing. Again closing. So this is balanced, right? There are opening, closing, closing. So this is one pair. This one is one pair. This is fine as of now. And let's see all the letters, lowercase letters, that there is like no significance of those, because obviously that is valid only. We have to just check for brackets here. Now see, after here we are getting a closing. But corresponding to this closing, there is no opening. No opening, right? That means this closing, this closing is a extra closing which needs to be removed. Because of this, our string is not valid. If we remove this extra closing, then our string will become valid. So what we have to remove? We have to, the question is we have to remove minimum number of parentheses, right? So here what we will remove? This one. We will remove, and the output will be this one, Lee, then this opening bracket, T, then we have this CC, then O, then this closing, and DE. This will be the output. So this closing bracket which is unnecessary will get removed. Fine. Other thing what we can do is we can remove this one. So yeah, like we can remove, what we can do is, if this is here, like yeah, something like, so there are different cases, right? Over here if you see, this is also acceptable, then this is also acceptable. Fine. Now let's see the other test case, which is this one. So in this, so from this test case, what we got to know? We got to know that if there is any extra closing bracket, that we need to remove. Fine, this is one observation. Let's see the other test case. So see, let's the other test case we have is A, then we have closing bracket, then we have B, then we have C, and then we have D. Over here, let's see now what is the case. See, A is fine, it's a character, it's fine. Then we are getting a closing bracket. See, there is no opening yet. You can say count of opening as of now is 0. Count of opening is 0. But count of closing bracket, count of closing is 1 because we have encountered one closing. So now it's 1. So do you think this case is valid? Should it be there that 0 is opening, like there is no opening bracket but we got a closing? This is not right. Fine, because for like if there is a closing bracket, first of all we should get an opening bracket. So this case is invalid because here count of opening is less than count of closing bracket. Fine. So here what we need to do is we need to remove this closing. This is making our string invalid. So we will remove it. After that, B is fine. Here we have opening bracket, so that is fine. Count of opening becomes 1. And then we have a closing, so this is making 1 pair. And then D. So this is fine now. So what we have removed? We have removed this closing. A, B, C and D. This is the output. So guys, see, from this test case what you got to know? You got to know that this could be an invalid case. This could be an invalid case where count of opening, if count of opening is less than count of closing bracket, that means closing brackets are more, then it means that that is an invalid case. So in that scenario, we have to remove the closing one. Closing bracket we need to remove. So this is one observation. So just do one thing guys, like write down these observations so that you can think of the approach, right? Now let's see this one, this test case. So here what we are doing, basically we are approaching the problem. Now we have this test case, something like this. Fine. So here see, same case. We have count of closing. We have count of closing, which is here also we get a closing. Closing count becomes 1 and count of opening is 0 initially. So here we get closing bracket, so we increment its count. Now here 1 is greater than 0. That is closing count is greater than opening count. Opening count. But that is incorrect, right? Obviously opening should be always greater than the closing or equal to. Hence this bracket needs to be removed. This needs to be removed. Similarly, so if we have removed it, count of closing let's say becomes 0. Again we go here. Again count of closing becomes 1. This is a closing bracket. And again count of closing is greater than opening count, 0. 1 is greater than 0. Hence this also needs to be removed. Then we get a opening bracket. So let's say count of closing is 0 now because we have removed these two, right? Then count of opening is what? 1. So this is fine. This is fine. 1 opening count should be greater than closing brackets count. So we go here now and again count of opening becomes 2. So guys, see, according to this, is it fine? But do you think like this string is, if we remove, see, what we have discussed till yet is that we are removing these closing, right? So if we remove this closing, in our string, these opening will be there. But this is also not a valid string, right? We cannot have only opening. There should be closing also for that. So after C, what you can see is that after traversal, we are still getting some opening in the string, which is not correct, right? We will discuss this case afterwards, right? We'll discuss this case in the second approach. So from these cases, whenever there is a parenthesis problem, right? In most of the cases, what we can use is stack, because here we have parenthesis. We have to deal with parentheses, right? So let's see how we can do it using stack. Then we will optimize it. So Lee was there. Then we have this P, then we have O, D, E, and so this was the test case, right? So see what we will do. We will take a stack. Right? And what we will do is if we get an opening bracket, see, same basic thing which we always do for parenthesis. If we get an opening bracket, we push it in the stack, push in stack. If we get a closing bracket, fine, if we get a closing bracket, we will check the top of the stack. If top of stack has a opening bracket, then we can pop the opening bracket because we got a pair. So closing bracket is there and top of the stack is opening, so we got a pair, since we can pop that opening from the stack. Otherwise, if the stack is empty, so we will not do anything. Stack is empty, do not do anything. Fine. So let's see how we can do this. So yeah, let's see. So what we are doing over here is we will traverse this string. This is a string given to us. First of all, we will go to L. So character we will not push anything. So just if character is there, just move forward. Now we are getting an opening bracket. So whenever there is opening bracket, push it in the stack. So in the stack we pushed opening bracket. Then guys, don't confuse this. This is C. This is C letter, right? C. So then we get T. So we will just move forward. Then we get again an opening bracket. This is the opening bracket. So we'll push it in the stack. Then C is later. Push. Just continue. Then we are getting a closing bracket. So see guys, we are getting a closing bracket. So now when we are getting a closing bracket, what we will do, we will check the top of the stack. Is top of the stack opening bracket? Yes. So this bracket and this bracket, that is this and this, is making a pair. Hence we can just pop it out and we will move forward. Fine. Now O is the letter, just continue, and then again we are getting a closing bracket. So when we are getting a closing bracket, we check the top of the stack, it's opening bracket. So this closing and this opening is making a pair, hence this is fine, so we can pop it. Now we go ahead, D, then we go to E, and then we are again getting a closing bracket. So again we are getting a closing bracket, but now see guys, now the stack is empty. That means when the stack is empty, this closing bracket is, there is, what we can see from here is that for this closing bracket, there is no opening bracket. Fine, there is no opening bracket. Hence, this is an extra bracket. This is an extra bracket. Hence, we will remove it. So now how will I know that, okay, I have to remove this one? What you can do basically, because after this also we can have a string, na? Like, let's say this is in between. For example, after this we have some letters and some brackets. So I have to remove this one because this is an extra one. I will replace it with some character. Let me replace it with hash. I will replace it with hash. And I'll move forward in the rest of the string. So once after I have traversed this entire string, what I will do is I will traverse this entire string again. And wherever there is a hash, I will remove that character, right? So that means I will, using this hash, wherever hash is, it means that you have to delete or we have to remove that character. Remove that parenthesis. Fine. Remove that parenthesis. So that's like using, like you can take any symbol, star, any dollar, any symbol you can use for that. Whenever, so for this case, what it was, that if there is a closing bracket extra and the stack is empty, means there is extra closing bracket, so just replace it, because that we have to delete. We have to remove that. There could be one more case. So here what was there? Here there was that we get a closing bracket, but there was no opening for that. No opening. Fine. That is stack was empty. What if there is opposite case? There could be opposite case also, na? That is, let's say our test case is something like this. We have leet. So it was like this C. Then what it was? O. D. E. Something like this. Now there I'm not like having extra closing here in the test case. Earlier we saw this one. Now there is extra opening here. Fine. So let's see how this will be happening. So see, first of all we get an opening, we push it in the stack. Then again we get an opening, we push it in the stack. We get an opening, we push it in the stack. Now we're getting a closing. So when we get a closing, we'll check the top of the stack, it's opening, pop it. Then we again get a closing, we check the top of the stack, it's opening, pop it. Now see, after we have traversed this string, stack is not empty, it has still an opening bracket, meaning there was extra opening bracket, and for this opening bracket there was no closing. So it's opposite case. Earlier what we saw, that there is a closing bracket, for which there was no opening, that is stack was empty. But now what we saw, that here stack has the opening bracket and there is no corresponding closing bracket for this opening bracket. So in that case also, what we will do here now, how I will know that where this opening is, which opening is it this opening, is it this opening, or is it this opening? So what I will be doing is, I will not store this opening like this, I will be storing the index of the opening bracket in the stack. So I will be storing 0. For this opening 4 will be stored, for this opening 6 will be stored. So when this is there, I will now know that 0 index opening bracket is the extra one. So when I'm traversing this string again, I will replace this opening with a hash. So this here now hash will come, and when I'm traversing it again, I will remove this hash character. So now this I will remove. So this is how the stack approach is going on. Let's see the code once, it will be more clear. I'll highly recommend just dry run once for the stack approach. So see what we are doing here is, so see, we have taken a stack, fine, and in integer we have taken. Why integer? Because we are storing indexes. We saw why, fine. If you didn't understood, just watch that part again. After that, what we are doing is, if there is opening, just push it in the stack. If there is closing, if stack is empty, fine. If stack is empty means that is an extra closing bracket, replace it with hash. Otherwise just pop whatever is in the stack, fine. Now if stack is not empty, that is this case, that is after traversing this string, if stack is not empty means there is an extra opening bracket. So for that, in S at that index, just add hash. So what I am doing is, at 0 index I am adding hash here, and then just remove that from the stack. So I am just removing this from the stack then. So this will be a while loop, and after that what we am doing, I have taken this output string, and wherever it is hash, like if the character is not a hash, I am inserting it in my string, my output string, and I am returning it. So if here it's hash, I will not take this character, I will take this L, I will take this E, I'll take this opening bracket. Wherever it is hash, I'll not take that character, fine. So this was stack approach. I hope you understood this approach. Time complexity is O of n, we are doing single traversal, and space is also O of n because we have taken a stack. Now this extra space is what we will optimize, fine. So let's discuss how we can do that. Now the second approach, which is the optimize approach, right, that also we saw from a test case only. So if you remember when we were discussing this test case, this one, there was a concept of, see, you will automatically think, right, see, over here we have this C and D. See, over here what concept we were using, if the count of opening brackets is less than count of closing, then that closing bracket needs to get removed, right? So if that closing bracket needs to get removed, we will replace it with hash, right? Let's discuss that. So see, let's say count of opening is 0 initially and count of closing also initially is 0. We are starting from here, so character, just skip it. Now we get this closing bracket. We're getting this closing bracket, right? So let's do one thing. Let's take single count variable only. Don't let's why to complicate things. We will take a single count variable only. Also, let's see the code also side by side for this. Fine. So basic, it's very easy approach. Let's see. So here, see what we are doing is we are taking this count variable. We initialize it with 0. Fine. So I'm taking a count variable and I have initialized it with 0. Now I am traversing this string. String S I am traversing. If there is an opening bracket, I increment the count. Fine. And if there is a closing bracket, I check if the count is 0. If count is 0, I'll replace the character with hash. Otherwise, I'll decrement the count. So see, here count is 0 and we got a closing bracket. We are getting a closing bracket. That means we are going here and we got a closing bracket. We get a closing bracket and right now count is 0. Means this is an extra character. So we replace it with hash. So we are replacing this s of I with hash. So here in place of this hash will come. Fine. So we'll go forward. Now B is a character, skip it. Now there is opening bracket. So when there is opening bracket, increment count. Count becomes 1. Then we go ahead, C is a character, skip it. Now there is a closing bracket. So when there is closing bracket, count is not 0, count is 1. So we will decrement count. Now why we are decrementing count? Because we got a pair, right? We got a pair, so we are decrementing. So this count is the number of, you can say, left pairs. Something like this you can say. So this has become one pair, so we are decrementing count. This is gone. So now we get D. D is the letter, just skip it. So after this, see, after this, we will traverse this string again, and wherever it is hash, that character we will not add in our. So here, see, we are actually doing the same thing which we did in the stack approach here for getting the output string. We traverse the string and wherever there is no hash, we push it in the answer string. So here A will be pushed, then B will be pushed, hash will not be pushed. Then C bracket D. So this will be the output. Fine. Now this is simple, right? This is simple. There is one case in this approach as well. Let's say we have this test case A, B, C, and let's take it as something like this. So here D, this is an extra bracket. This is an extra bracket, right? So here what will happen? Let's take count as 0. Count as 0 we have taken. And earlier, let's see what was the test case. So yeah, let me do one thing. Let me take it as like this. So here we have extra opening, right? This opening is extra. So count is 0 initially. We go to A, continue. We go to this opening bracket. So whenever there is opening, increment count. Then we go to B. So B is the letter, skip it. Opening, increment count. Then C, then D. So then bracket. Just decrement count. Whenever there is closing bracket, right? Whenever there is closing bracket, we decrement the count. Minus count. And then we get D. So D, we'll skip it. So see, after this, like, no, we didn't go anywhere got count as 0, right? Count as 0 we never got. So nothing is replaced with hash. But ideally this opening bracket is the extra one, right? So for this what we will do? So see guys, when there was an extra, here extra closing was there, right? Like this was the case. Extra closing was there. So what we do, we traverse from the starting, and whenever we get a closing, we decrement count, and whenever we get opening, we increment count. But now we have to, here extra closing was there, here extra opening is there. So for that, what we will do? Just the opposite. Earlier we were traversing from left to right. Now we will traverse from the back to front. If we get a closing bracket, we will count increment count. And if we get a opening bracket, we will decrement count. Opposite. So see, this was for the extra closing bracket, and this other one is for extra opening bracket. Fine, opening bracket. And for this, what we are doing is we are traversing from right to left, back to front. If it is a closing, increment count. If it's opening, same thing. And at last, this can be done. So this is your task, right? You have to dry run this on this test case and see how this is getting deleted. I hope you understood the problem and the approach. Dry run once the second approach, you'll better understand. And let me know in the comments if you have any doubt. If you found the video helpful, please like it. Subscribe to my channel, and I'll see you in the next video.